Okay, so in this, so the last topic I'm going to cover from this chapter is something called Gaussian elimination. So essentially, in this topic, what we do is we get an understanding of how to use sort of the knowledge we've acquired doing this matrix chapter to solve a fundamental problem. So the fundamental problem is, suppose you're given a system of equation. Okay, so you're given these three equations, and there's three unknowns: x1, x2, and x3. So what we're trying to do is we're trying to use these three equations to find solutions for x1, x2, and x3. So typically we're used to working with two equations and two variables, right? And you can do the simultaneous substitution, and it's easy to solve for x1, x2. But what do you do when you have these three equations with three unknowns? So one common way to go about solving this is, you try to think of ways in which you can eliminate x1 and x2 from your last equation, so that you're just left with an x3 equals to something. So that means that, so what you do is you try to use your equations 1 and 2 in such a way, you manipulate them, and then you try to add them to your last equation so that x1 and x2 gets eliminated. So what would be one way of doing it, right? So notice that over here I have a minus 3x1. So what I could do is, one approach for this could be, okay, let's say I take my equation 1 and I multiply it by 3, okay, the number 3. So what do I get? So my equation 1 becomes 3x1 plus 3x2 plus 9x3 equals to 10. Now let's take this and let's add it to your equation 3. So what is going to happen? So your equation 3 is now going to become, this is going to become 0 plus 5x2 plus 11x3 and sorry, I think so we multiplied by this was 6, right? Sorry, because I multiplied this equation with 3, so this became 6. So when you add 6 to 10, you're left with minus 4. Okay, so your equation 3 has now been transformed into this form, where you can see your x1 has been eliminated. So now you have a new system of equations, right? So you can now you can rewrite your equations like this: x1 x2 plus 3x3 equals to 2, 2x2 minus x3 equals to minus 7, and then from here you've eliminated x1 and you have 5x2 plus 11x3 equals to minus 4. Okay, so you've taken this, you've done this manipulation, and you have managed to, in your last equation, you've managed to eliminate your x1. Now try to think of, one more step which you can do now to eliminate x2 from your last equation. So how can you do that, right? So again, what you can do is try to see, okay, I have in my equation 2, I have a 2x2. Over here, I have a 5x2. So if I could transform this into 5x2 by multiplying my equation 2 with something, and then if I could add it to my equation 3, so I'm trying to make this into a 5, so that if I add, I'm trying to make this into minus 5, so that if I add it to this one, this 5x2 is going to get eliminated. So how can I do that? So one way you can do this is, if you take your equation 2 and you multiply it with minus 5 by 2. Because what's going to happen is, when you multiply this equation by minus 5 by 2, your equation 2 is going to transform. When you multiply this, minus 5x2 minus is plus 5 by 2 x3 equal to minus plus 7 5 is a 35 by 2. Now you can take this and you can add it to here, because why? Then your 5x2, when you add it to your equation 3, this and this is going to cancel out, and what you're going to be left with is, you're going to be left with something. So your equation 3 is now going to do, equation 3 is now going to transform. So you add this to your equation 3. So your 5x2's get cancelled. And what you're going to be left with is 27 by 2 x3 equals to 27 by 2. So you see from here, you get a solution, right? You get a solution that your x3 is equal to 1. So through these manipulations, you found a solution for x3 equal to 1. Now once you have your x3 equals to 1, now you can use this, you can plug it here or here, you can find a solution for x2. Once you find x2, you know x3, you can plug it here and you can find solutions for x1. So that is how, when you have a system of equation with 3 equations, the process is lengthier, right? You have to think of how can you manipulate your equations in such a way so that in the last equation your x1 and x2 gets eliminated. And the particular way I've done it is, first I've multiplied my equation 1 with number 3, then I've added the resulting equation to equation 3. This gives me a new system of equations, and then from here what I did was, now my target is to eliminate x2. So I multiplied my equation 2 with 5 minus 2. This gives me a new equation 2, and then I added to equation 3 to eliminate x2, and then I get a value for x3. Okay, so this is a way where when you're working with 3 equations, this is how you can solve them. So in my next video, I'm going to show you how we can do this. This seems a bit messy, but there's a nicer way of doing this, which is by transforming these equations into a matrix form and then doing the same kind of elimination process. Okay, so that is known as elementary row operations, and that's going to be the last video I'll do for this chapter.